After a stroke, individuals are often fit with an ankle-foot orthosis, or AFO, to treat foot drop. AFOs can be adjusted in stiffness and joint motion to improve stability and walking. Currently, orthotists tune the AFO using observational gait analysis and patient feedback. They will observe things like toe clearance and swing and foot-to-floor angle at initial contact. However, this trial and error approach can be time-consuming and susceptible to variability. Our Smart AFO system fills an unmet need by combining wireless sensors in the AFO with a mobile application for quantitative biomechanical assessment necessary for AFO optimization in real time. This system builds upon prior research that found the gait of persons affected by stroke can be systematically improved by changing 3 key stiffness and joint motion parameters in articulated AFOs. Smart AFO is instrumented with electronics and sensors that allow for the data to be wirelessly streamed in real time via Bluetooth to a custom mobile app. The mobile app can connect to one AFO for a unilateral user or to 2 AFOs if the user has bilateral AFOs. This static alignment page allows the orthotist to visually understand if the patient's center of pressure is anterior or posterior of the ankle joint and make an adjustment to the static alignment if necessary. The orthotist will have the patient walk with the Smart AFO to record force and motion data. As the patient walks, sensor data from the AFO are being recorded in sync with video of the individual. The valuable video data provide visual context to the biomechanical data as a clinician reviews the patient's gait. A computerized tuning wizard compares responses to observational questions and key gait characteristics from the data, with optimal indicators to derive AFO adjustment suggestions. For example, the tuning wizard asks if there was adequate toe clearance during mid-swing. Rather than only recalling from memory, the orthotist can watch the recorded video to assist in evaluating the patient's gait performance. Throughout the tuning wizard, the orthotist will answer a variety of questions about the patient's gait and can use the video and sensor data for reference of the patient's gait performance. If there is a gait characteristic that is determined to be incorrect, such as the foot-to-floor angle shown here as too low, the orthotist will be provided guidance by the mobile app on a suggested AFO adjustment. For this particular adjustment, the mobile app in communication with the Smart AFO can provide real-time feedback on the angle adjustment for the orthotist. The orthotist can choose to adjust the AFO and then collect a new set of gait data with the new AFO settings. An iterative process is used with the tuning wizard guidance to determine the patient's AFO settings for optimal gait. These settings can be transferred to a non-instrumented low-cost AFO. The Smart AFO mobile application is a key component of the Smart AFO system that provides data visualization and guidance during the AFO tuning process to optimize an AFO user's gait. To ensure improvements are made in patient care, there must be ways to measure this. Smart AFO is a tool that measures key gait characteristics with an objective quantitative approach and supports clinicians in their orthosis adjustments for optimizing patient function.